Hi everyone, let's look at more exponential equations, and these have been kind of graduated up in level of difficulty. I highly recommend that you follow through with my stop and watch it notation here and watch the videos built into WebAssign problems. So I'm trying to balance coverage with the problems that are covered in our videos in WebAssign versus the content videos. Okay, now what you see before you is a problem that says use common logarithms to solve for x in terms of y. Now this equation immediately looks more complicated to us because there's both an x and a y in the equation. But try to remember the variable that you are solving for. So what I see here is an equation that is exponential in terms of the variable x, and that kind of gives me a insight into how to solve it. So first I would multiply both sides by 8, and then what I would have is basically two separate exponential terms. So I'd have 8y equals 10 to the x plus 10 to the negative x. And now going back, our original equation is y equals 10 to the x plus 10 to the negative x divided by 8. Cross multiplying, if you will, leads us to the statement I just wrote down. And the question you have at hand is, what do I do with this? I mean, what's happening here? Well, a tip that we give in our watch-its is that if you have 10 to the negative x, rules of exponents allow you to write this as 1 divided by 10 to the positive x. Okay, let's try that and see what happens. What we're going to do is keep working at this until we get something we recognize. Now, if I multiply both sides of this equation by 10 to the x power, I will certainly cancel the denominator on the right hand side, but each of the other terms will also be multiplied by 10 to the power of x. Okay, so I'll just walk through distributing here, and I'm going to try not to skip steps. Okay? Alright, so basically what I have is the coefficient 8y times 10 to the x power equals, in this case I could write this as 10 to the 2x, which is the same as 10 to the x quantity squared, and then 10 to the x divided by 10 to the x gives me 1. And I see here an equation that I have seen before in earlier examples, which is an equation where you have 10 raised to the 2x as well as 10 raised to the 1x in the problem. And when you encounter this situation, it's really a quadratic equation in 10 to the x in disguise. Think about it this way. 10 to the 2x is really 10 to the x squared. 10 to the 1x is really 10 to the x to the first power. So if I were to do a substitution, u equals 10 to the x, then the resulting equation would be 0 equals u squared minus 8y times u to the first plus 1. And if I'm operating in my substitution world or the original equations world, the quadratic coefficients are a equals negative 1, or excuse me, a equals positive 1, b equals negative 8y, and c equals positive 1. Okay? So whether or not I substitute, I do need to recognize that this equation here is quadratic in 10 to the power x. Okay? So let's use the substitution equation for just a moment. We would have u equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a, or u equals 8y plus or minus the square root of the quantity 64y squared minus 4, all divided by 2. And you'd stop here if this were the original equation, but u is actually equal to 10 to the x, so I need to finish what I started. I'm solving for x. Okay, so I really have 10 to the x equals 8y plus or minus the square root of the quantity 64y squared minus 4, all divided by positive 2. Okay, now if you're faced with this situation, then if you have 10 to the x equals, you can solve for the exponent x by rewriting this in logarithmic form. And in logarithmic form, you're going to write this as log base 10 of the entire other side. But you need to pause and remember, in my earlier videos, I said it's real important for you guys to check these, to make sure that you check against the domain of the logarithm. So for example, I cannot take the logarithm of a negative number. So somehow I need to reason this out to myself. Okay, well, here's my reasoning. First of all, if I simply had the square root of 64y squared, I could think about that as basically the absolute value of 8y. Okay? And therefore, the square root of 64y squared minus 4 would be smaller than that quantity. Okay? So 8y plus or minus this guy would kind of depend on y. So let's, for the sake of argument for a moment, write this in a common way of saying that this is 8y. And think about this here. Okay? So you're basically saying you've got 8 plus or minus something that is smaller than 8y. Okay? Alright, well, you know that 8 plus something smaller than 8y is okay, that's positive. But 8 minus smaller than 8y, well, that's okay too. That's still positive. So they both check. But you don't assume that they both check. Please always check. Okay? So this entire expression is our final answer. Now, the good news is that you probably won't have to type this in. Your problem will have multiple choice selections. The bad news is you have multiple choice selections, so you need to really be careful and know what you mean. So we're not trying to trick you here. We just want you to reason out whether or not this portion of the problem is smaller or larger than this leading term here, and then make your decision based upon that.